Hello, and welcome to the 102 Carbohydrates lab. In this lab, we're going to be testing various sugars and also a couple food products for the presence of different types of sugars. The first test we're going to be doing is a starch test where we use a potassium iodide indicator. And when we add this indicator, anything containing starch will turn blue. There we have an orange, a potato, and a piece of bread. Now we're doing the same test with a solution of different sugars. We have fructose, glucose, lactose, sucrose, and starch. On the end, we're going to add some milk. Now when we add the potassium iodine indicator, the color of the indicator is yellow. So a yellow color is a negative test, and a blue color is a positive test. Next, we're adding orange juice to our series of sugar solutions, and we're going to do the Benedicts test. The Benedicts reagent is blue and tests for reducing sugars. In this situation, we're going to boil the tubes for about 20 minutes, and a positive test will be a color change, either rust colored or yellow colored. Here we're boiling for 20 minutes, and fast forward. The results are in the same order here: glucose, fructose, lactose, sucrose, starch, orange juice, milk. Compare that to what it looked like before and after. This test is the Slavanov test, where we're going to take our same solutions as before, refill new test tubes, and then add some 25% hydrochloric acid and a little resorcinol. After the resorcinol is added, we're going to again heat this up in the same boiling water bath, and a color change will occur. At first you can see there's not a whole lot of change. Maybe one of the tubes is kind of slightly pink. That might be the fructose. The orange juice is still orange and the milk is still white. So we can't really tell anything right away, but we'll let it cook for a few more minutes, and we'll see that some of them have turned red, which is a positive test for the Slavanov. Glucose, fructose, lactose, sucrose, starch, orange juice, and milk. There's your final results. Our final test here is the Tollens test, and in this case it's a little bit more of just a demonstration or something fun to do with a tube. We're making a silver ammonia solution, starting with silver nitrate, adding ammonia, getting that all to redissolve, then we're going to add some sodium hydroxide, use more ammonia to get that to redissolve, and we have a nice clear silver ammonia solution. This will then react with any reducing sugar to plate silver metal out on the inside of the tube. you have a really clean tube, this will make a mirror all around the inside. And it's a pretty cool looking demonstration. There you go. Not part of the procedure, but I figured I would add it in, is we're going to do the tolerance test on the remaining sugars to see what happens. We pre-made some silver ammonia solution and we're just quick adding it to the remaining sugar and starch solutions, dipping it in a little hot water to increase the speed of the reaction, and then we'll see what happens. Here we have the results for glucose, fructose, lactose, sucrose, and starch. Since this is a test for reducing sugars, it's the same as the Benedicts result. For the last part of this lab, we're going to be testing some milk solutions and their reaction with a lactate capsule. So we measured out equal amounts of milk in two 50 milliliter beakers. We're going to leave one alone, and we're going to grind up a lactate tablet and add it to the other one. In order to let it work, we're going to need to let it sit for 15 minutes, so we'll just fast forward and come back 15 minutes later, where we test it with some glucose test strips. These test strips will change color in the presence of glucose. So on the left is a no color change, and on the right is a sped up 30-second time lapse of what it looks like for a positive glucose test. You should now have all the observations to fill in your DAS, and if you need any help, ask your online TAs. Thank you.